Good morning, students. So now we discuss depth sorting method. Okay. So depth sorting method. So image space and object space operations. So here sorting operations in both image and object space. Okay. So the scan conversion of polygon surfaces. The scan conversion of polygon surfaces in image spaces. Okay. Here there are different type of the basic functions. That is, surfaces are sorted in order of decreasing depth, and surfaces are scan converted in order comma and starting with the surface of the greatest depth. So these are the main two functions in the depth sorting. Okay, so first one is surfaces are sorted in order of decreasing depth. Surfaces are scan converted in order starting with the surface of greatest depth. Okay, so these are the main two functions. Okay, based upon that main two functions we have to implement it. Okay, so we are perform these basic functions first in the depth sorting algorithm, and it's also called as a painter's algorithm. So another name of the depth sorting method is it is called as a painter's algorithm. Okay, see how we can say it is a painter algorithm. See here. So it is referred to as the painter's algorithm. That is, in creating an oil painting, then first we can go for the first paint the background colors. Next one, the most distant objects are added, then the nearer objects, and so forth. Finally, the foregrounds are painted over all the objects. So in the whenever we have to create the different of the paintings, in that painting we have to define the first one is the background color, the next one is the what are the objects are added can find, then what are the near of the objects, and so forth, and finally the foregrounds are painted over all the objects. Okay, simply for example mountain or sceneries of the photo frames. For example, you can say the sea scenery, then it will assign the people, then assign the water, then assign into the stones likewise. So in that way we have to painting all the colors. In that way you can assign the sorting manner. In that way we can say that it is called as a painter's algorithm. So in creating the for example creating oil painting, so first you can paint the background color, what are the objects are added, what are the objects are the nearer to the particular painting, and what are the foregrounds or paint over all the objects. Okay, so here each layer of paint covers up the previous layer. Okay, so process sort surface according to their distance from the view plane. So that is the sorting the surfaces according their distance from the view plane. So in the view of the faces you can assign the sort surfaces. So the intensities for the furthest surface are then entered into the refresh buffer. That is, what are the intensities for the particular surfaces that may be into the refresh buffers. Okay, that is called in the refresh buffer we have to store into the what are the intensities of the particular surfaces. Okay, so taking each succeed surface in decreasing depth order, then can complete it we can take the all the succeeding surface in the decreasing of the depth order. So this is the process of the particular depth algorithm, depth sorting algorithm. That is, sort surface according to the distance, the intensities for the furthest surface are then entered into the refresh buffer. That is, we can store the intensities values of the particular surface in refresh buffer, taking each succeeding surface in the decreasing depth orders. Okay. See now, whenever we have take any one example for consider an object, that is, for example, you can take two objects, that is S and S dash. In S and S dash, we can take the Z axis if there is no overlapping. If S Z min less than S dash Z min, then it may be possible to overlapping. Then we can go for the different type of the test cases. If there is no overlap from the viewing of the Z plane, we can consider that one and we can find the shortest, like we can find the distant paths. Okay, if there is the possible of overlapping in that one, we can go for the different type of the test cases. So the first one is the bounding rectangle in the xy plane for the two surfaces do not overlap. So now we can draw the rectangle in the xy plane, the bounding of the rectangle in the xy plane if the different of the two surfaces are not overlap. And second one, surface S is completely behind the overlapping surface related to the viewing position. So To take two objects, that is S dash. So S is the completely behind of the S dash. That is a surface S is completely behind of the surface S dash related to the viewing position. And third one, the overlapping surface is completely in front of S relative to the viewing of positions. Okay, and that is completely in front of the S dash, S in the S dash. Okay, and next one, the projection of the two surfaces onto the view plane do not overlap. Whenever taking the projections, in that projection the two surfaces are not in the based upon the view plane do not the overlap. Okay, so these are the four test cases. For example, the first case will be succeed, go from the second and third one. If it is possible to overlapping, that is s minimum less than s maximum, so minimum greater than x maximum, then it may be possible to overlapping, then we can go for the second case. That means of the first case will be failed, then go for the second case, that is s is completely behind of the s dash. If also it may not be overlapping, then we can go for the third test case, that is the overlapping surface is completely in front of s related to the viewing of the position. If third case is also failed, then we can go for the projection of two surfaces onto the view plane do not overlap. Okay, if it is also overlapping, then the four cases are failed. Now we can reorder the particular surfaces. See, if all surfaces pass at least one of the tests, none of them is behind the S, there is no reordering than necessary, and then S is scan is converted. If anyone is pass, then we can go. Then if there is no reordering, then we can convert the S. Okay, see for example, see here, 2, you taken the S and Y if there is no overlapping. For example, to here, S and S dash, S is completely behind of the S dash. See, S is completely behind of S dash, and here S dash is completely in front of the S. Okay, if there is any overlapping in one, then go for 2. Okay, if there is also no overlapping, then go for 3. If there is no overlapping, then go for 4. Okay, so likewise we have to check the all the test cases. In the all the test cases will be failed, then we can reordering of the given surfaces. See, if all four test cases here, if all four test cases are failed with S, then interchange the surfaces S and S dash in the sorted list. So now we can interchange the S and S dash. S, S dash and S double dash. Okay. So repeat the test for each surface, that is reordering the list. So whenever the four test cases are failed, we can go for the reordering of the particular test case. Okay. So these are the moving test cases, that is the boundary rectangle in the XY plane. Next one is the surface is completely behind of the overlapping. The next one is the overlapping surface completely in front of the S. Next one is the projection of the two surfaces onto the view plane do not overlap. Okay, see here. For example, we can take this one. If there is a possible to overlapping, this is possible. But in any one of the such case, if there is no possible to the overlap, then we can go for the third case. If it is also maybe some cases possible, but some cases not possible, then the test case 3 is failed. In that way, we can go for the fourth one. Okay, see in fourth one, for example, this one. Next, take another projection. See here. These are the projection 1. These are the projection 2. Okay, here it is the surface. Okay, it is also surface. Here, if there is no possible to overlapping the surfaces, but here the projections are overlapping, but the surfaces are not overlapping. Okay, in that way the condition 4 is success. For example, but here the surfaces are also overlapping, that is the test core 4 is failed. In that way we can go for the reordering of the particular surfaces. Okay, see, when it fails we can go for the reorder of the particular list, that is we can change the s and s dash of the position, that is sorted list of the particular positions. See, if two or more surfaces alternatively obscure each other, that is, it may be infinite loop and flank any surface that has been reordered to a further depth. Okay, it cannot be moved again. If an attempt to switch the surface a second time, see, divide into two parts to eliminate the cyclic loop. The original surface is then replaced by the two new surfaces. See, now we can check the backways and depth buffer. See, the backways prediction methods are the fast and effective as initial screening. It may be eliminate many polygons from the further visibility test. So, in the backways detection, what we have to do in the backways detection, we can detect the particular backside of the views and we can remove the particular views. Then we can remove the particular those views. That is the eliminate any polygons from the further visibilities. In general, this can't completely identify all the hidden surfaces. In some situations, it cannot be identify all the hidden surfaces. And depth buffer, that is a Z buffer or G buffer method. It is a fast and simple. In here we use the two buffers. The first one is a refresh buffer, that is we can store into the pixel intensities. And next one is a depth buffer for using to store the depth of the visible surfaces. That is the depth values will be stored in the particular depth buffer. In refresh buffer we can store in the pixel intensities. Okay. See, in a buffer method, an improvement on the depth buffer approach, that is an additional information, anti-aliased and transparent surfaces. See, in other visible surface detection schemes are there is scanline method, depth sorting, that is the painters, and Bsp3 and area subdivision method and Octi method and ray casting. See, what is the Bsp3 method? So Bsp3 is a binary space partition method. So whenever we can allocate the sum of the objects, that object will be assigned some spaces. In that way, we cannot be assigned to the which is the in front of the view and which is the back side of the view. Okay, in that way, we can go for the BSP trees. In the binary search binary space partition trees. See, for example, we have take three objects. See, object one, object two, object 3. Okay, now we can take any one of the partition. For example, take the partition that is called as a P1. So P1, it is a this object will divide into the two parts. In that we can assign it is A, it is B, it is C, it is D. Okay, now in the P1 has, it is the in front of the P, it is the back side of the P. Okay, in front of the P we can assign the P1 equal to, so P1 equal to front is A C. Okay, then back is B and D. Okay, now take another partition, it is called as a P2. In P2, AB is the front side and back side is C and D. Okay. Now, when complete the partition, then we can go for the tree. This is called as a binary. In each node has a two childs. That is, now can take P1. So it is P2 because of there is a two partitions. Okay. Now we can take left and right. See here, this is the front, front, this is the back. Okay, it is a front, it is a back, it is also back. Now we can take P1 front and P2 front, that is A, C and AB, but here the common point is A. Now we can take it is as A. Next, P1 front, P2 back, that is P1 front is AC, P2 back is CD. The common point is C. Now we can take it as a C. Next, P1 back, P2 front, common point is B. Now it is a common point B. Next, P1 back, P2 back is common point is D. So likewise, we have to find the A, B, C, that is the which is the in front of the values and what are the backside of the values. In that way, we can find A, C, B, D. Now we can go from the conversions. In the conversion, first of all, we have to define the which are the backside of the views. Then after completing the backside of the views of the scan conversion, then we can find the front view of the scan conversions. Okay, so likewise we have reached to the Bsp3 method, that is a binary space partition tree method. That is SP means space partition. In that way, if I can assign the space, that assigned space will be partitioned. Okay, so this is the concept of the Bsp3 method. Okay, next, area subdivision method. So what is the area subdivision method? See, when we can allocate the space, in that space we have divided the four parts because of we don't know how where the particular area will be allocated. In that way we have defined the four parts. If the area will be assigned in this place, now it will be also divided to the four parts, and also it will be allocated to the four parts. So likewise, we have to define the smaller of the all the things. When it will be completed, that means of in each value of assigned to the one pixel value. When in that way, we have to stop the particular process. Okay, see, that is object considered as a space. Here the complete space should be divided into the smaller axis until area of the surface are no surfaces. When divided them into all the more surfaces are distance is smaller. That is completely dividing all the one pixel value. Okay. Okay, this is the area subdivision methods. That way you can assign the only one pixel value. So it will be divided into the four areas and it will be used, then also divided into the four areas. Likewise, it will be divided when it only the one pixel value. Okay, so where the divided into the four areas, now we can observe the areas of the particular surfaces available in the test case should be divided into the four phases. Okay, so the first one is surface surrounding of the surfaces, and second one is overlapping surface, third one is the inside of the surface and outside of the surface. Outside of the surface. Okay, so in the surrounding of the surfaces we can find which is the value of the surrounding. See, for example, this area, this is an area, that area will be surrounding in the one polygon. Second one is the overlapping. See, so here the fourth is the overlapping. The next one is inside of the surface, so it is the inside of the surface. The next one is outside of the surface. So likewise we have to check these four parts, that is the four different of the cases. So first one is the surrounding surface, second one is the overlapping surface, third one is the inside of the surface, fourth one is the outside surface. So based upon that, so inside and outside and the surroundings is no problem. Then when it will be uh, overlapping, then we can construct the position, that is we can using to the all the methods when we find the which is the front view of the surface and which is the back view of the surfaces. It is called as a area subdivision methods. Okay. So these are the main visible surface detections. Okay. Next. So Octi method. So what is an Octi method? Octi method is we can define the particular 3D cubes in 8 partitions. Okay. That is an Octi method. That is called as an Octi methods. Okay. Next. So scanline method, depth sorting method. Next Bsp3 method. Next one is Octi method. See, in the Octi method is in a hierarchical tree structure called octrees. So what are the hierarchical structures there? It is called as a octrees. So are used to represent solid objects in some graphical systems. Mainly we are using to the medical imaging and other applications that require to the place on the object cross sections. Commonly we are using to the representation. So the tree structure is organized so that each node correspond to the region of the particular node. See, the Octi encoding procedure for a three-dimensional space in a extension of the encoding scheme for the two-dimensional spaces. It is called as a quadratic encoding. In the quadratics are presented by the successively dividing the two-dimensional regions from the one or more each of the quadrants for the region. Okay, it will be divided into the four quadrants and each quadrant will be allocated to the four values. Okay, so likewise in the each quadrant will be four values and each quadrant will be divided into the four areas, then each part of the area will be divided into the four values. In that way we can assign to the quadrant. In when go for the region of the 8, that is a three-dimensional space, and the data elements in the represent line as the octet code, that is the 8 values will be assigned the particular each and every octet codes. Okay, it is called as the octrees methods. Okay, it is called as the octrees method. Thank you.